Hi everybody, the purpose of this video is to help you finish up the work that you need to do for your lab report in experiment 7. Now keep in mind that friction is typically defined as follows. Your frictional force, F of S, will always be equal to your coefficient of static or kinetic friction times your normal force. Okay, so essentially, if you're going to do a linear regression, this is going to be y, this is going to be x, and your slope will be this. So with that in mind, this right here is going to be x, okay, your normal force. Now, F of S, the force associated with the hanging weight, was you basically trying to find the amount of force necessary to counteract friction, which of course would be equal to the frictional force, just in the opposite direction. So this is our estimate of the actual friction force. This is our normal force, and from that we can figure out what this bad boy is. Now the way that we're going to do that is by taking this particular graph right here, or this line, our normal force, and putting it into this column in Excel, and taking our frictional force right here and placing it in this column. We did that for the static case, and of course we also did this for the kinetic case. Notice that there is a point less. Okay, now that we've done that, we can go ahead and use linear regression to compute the slope. How are we going to do that? Well, what we want to do is come over here, like right about here, and the equation or the formula to do that is, well, first it's equal side L I N E S T. So we can go and click on that. Now the first thing they want are the y values. The y values are in the second column. This will be the y values. So you can move to here, press enter, and highlight those values. Or of course you can use a mouse. Once you have the values you want, you can hit comma, and then it's time for the x values. The x values are right next to it. There you go. Highlight those. Okay, and now you can actually close your parenthesis, hit enter, and there you go. Now this right here is the slope, and this right here is our y-intercept. We can do the exact same thing down here. Once again, L-I-N-S. You can just hit tab to complete it. Once again, these are y's, comma, and these are x's. Hit enter. This is your slope, and this is your intercept. So this right here is our estimate for the coefficient of static friction. This right here is our estimate for the coefficient of kinetic friction. And it does make sense. Notice that this is 0.151, this is 0.102, and we would expect the coefficient of kinetic friction to be less than the coefficient of static friction. So those would be my values here. I need to get out of that. Here I would have 0.151 if I just want to go to 3 significant digits, and over here I would have 0.102. Okay, and that takes care of that. Now the other thing that we need is a graph of these two things. Now the way that we can do that, since this is x and this is y, is we can highlight both. For the static case, highlight these values. I can go to chart. I can go to this one right here, scatter charts. I want scatter charts with straight lines. So it'll be this one right here. All right, hit enter, and there you go. Now there's a couple of things that you can also that you're going to need to do, because if you read the instructions, I want, being demanding here, I want the graph to be properly labeled with the title and an x-axis titles and y-axis titles. Okay, what I can, so this right here, I can compute. Okay, I can add chart elements, axis titles, the primary horizontal. That is my normal force, so that would be normal force in newtons. All right, and then for my other chart element, that would be primary vertical. That would be, and there you go. That is probably the least that you actually need for this to be acceptable. Now, if you want to be cute, you can come on down and actually plot yourself the regression. That would be a trend line, which is linear. Okay, there it is. Now we can go back in here again and hit the more options thing. Okay, and we can do things like make sure it's linear. We can display the equation on chart. And well, I thought I displayed the equation on chart. Let's try that one more time. More options, trend line options, display equation on chart. Don't know why I don't see it. Oh, there it is. I guess I had to click it a couple times to make sure it's there. And I can close that, and there it is. Now I can also, if I wanted to, make that a little bigger so it's easier to see. I can just basically click on that, go to Home, click on this to increase the font, move it around, and that is perfectly fine. If I also wanted to be even cuter, I don't really need this thing to go to 12, so I can click on the x-axis, right-click, click Format Axis, click the little bar thing, it's already there, and I can just make this the max to be equal to 10 and not 12. That will give the graph a little more detail. And as you can see, this does plot a straight line reasonably well. There may be some issues here which is causing this thing to not go down to 0 the way it should, but once again that's a perfectly acceptable graph. And now to put this in your lab report, just highlight it, hit copy, come on down to the appropriate spot, which would be right here. Well, blew right by it, sorry. Right here, hit space, or hit paste, and there it is. Okay, and now we get to do the exact same thing with the other one. So for this one, we are going to make our stuff visible. We can highlight both columns, insert, charts, that one right there, and there is my chart title. That seems a little weird, but that's okay because most of this data is contrived anyways. And then once again, I need to fix my titles, so I can change this one to kinetic friction. There it is. Okay, well, let's try this one more time. I'm going to go to chart design, add chart element. Let's try that one more time. Chart title, above chart. I think I may have forgotten that. Okay, now kinetic friction versus normal force. Hit enter. There we go. Okay, now for my x-axis, axis titles, primary horizontal, normal force in newtons. Okay, primary horizontal, primary vertical, kinetic friction in newtons. Okay, there it is. And if I want to be cute on this one as well, I can add a trend line. So come down here, trend line. Actually, I'm just going to go to more trend line options. I'm going to hit over here. There we go. Linear, automatic, display equation on chart. And there's my equation. I can close this out. I can make this bigger if I want to, and well, I do. So let's go ahead and make that a little bigger so it's easier to read. Get it out of the way. And I can also, if I feel like it, change my x-axis. I can right click there. I want to format the axis. I want to make sure this is highlighted. I can change my 12 to 10. Okay, there's my graph. And now I can go and I can paste this. I can copy it and paste this in the appropriate spot of my lab report, which would be right here. And there it is. Now, one of the things I don't like is the fact that it split the page, so I guess what I could do is just come over here, and I kind of want both of my graphs on one page. It's not necessarily necessary, but I guess you could say I'm being anal. Okay, and there you go. Here is my kinetic friction graph, and here, no, my static friction graph, and here is my kinetic friction graph. Once again, this is my coefficient of static friction, consistent with what's up here. Okay, and this is my coefficient of kinetic friction, which is consistent with what is here. And that is pretty much how it's done. So if you have any questions, please feel free to send me an email. And this is Bob Boyle, signing off.